Alright, welcome back. This is the Intermediate Series, Lesson 7, and I'm Chili. Like I said in the last lesson, today we're going to be talking about the keyboard. We're going to be upgrading the keyboard. So we're going to do a little bit of Win API stuff, and I'm going to show you guys a little bit of the STL, or the Standard Template Library. Just a quick little preview of that. But first, I just wanted to go over one thing that I forgot to draw your attention to in the last tutorial. Graphics here. We overhauled the graphics object to use a buffer in system memory when it does all the drawing, a kind of I don't know, like a pre-buffer or an accumulation buffer. I don't know what you want to call it. But we use this system buffer, and it speeds up our blitting, especially our alpha blitting, a hell of a lot. And that's great. But one thing that I wanted you guys to, I don't know, kind of realize, if you haven't already realized it, is that all the graphics functions we've been building up until now, they have been utilizing the putPixel function, right? Here we use putPixel, and I mean in the alpha, we also use getPixel, right? So all of these different drawing functions, draw characters, draw circles, lines, disks, whatever you want, they all go through the putPixel. And that means that when we change the way that we accessed video memory, the only thing we really had to change is we just had to change putPixel and getPixel. And once we changed these functions here, we didn't have to touch our, for example, our draw line or our draw disk, draw circle. We didn't have to touch any of those functions. They were just good to go. And that is one of the benefits of making functions and breaking things down into functions, making all of, I don't know, your program work through some common interfaces. When the back end changes, like, for example, in our case, when the way we handle the graphics memory changes, all we have to do is change the interface to the back end, and then all the stuff that depends on that will automatically be, it'll just work. And that's the goal, it's to just work. And that's what it did. Now, if I hadn't used putPixel in these functions and I had made them all just directly access the video memory, it would have been a much bigger pain in the ass to update this whole framework. So, and just to let you know, way back when I got comments on my videos saying that it would work faster if we just took this this code here and put it right where putPixel is. So not, instead of calling a separate function, just put that right in there. But in fact, it is not faster. It's exactly the same speed, because what the compiler does when you do a release build is it inlines these functions. It just takes this code. It ignores, first of all, it ignores all these asserts in release mode, and it just takes this code and it just copies it and pastes it right in here for you. So the end result is the same, it's just the code is a lot neater. That's what function inlining is, and if you don't know what I'm talking about, you can Google that shit. Inline, function inlining, just Google that and learn. So you're not getting any speed by putting it right in the function here. You're just making your code shittier. So break it down into separate functions, and you will benefit. That's what I wanted to say in at the end of the last episode, but I didn't. Now for this one, I'm just gonna be working off of the alpha that we did in lesson 6. So it doesn't really matter what version of the framework you use, but you might as well use the same one as I'm using. So yeah, keyboard. Alright, so the goal here, I mean, the way the keyboard system works right now, it has two major flaws. The first flaw is we've only got like 6 keys. And if you want to add a new key, you've got to add a function here, you've got to add functions here and here, and wait. Yeah, you got to add a pressed and released function to the server. You've got to add a kind of a get function here to the client. You've got to add a variable here, and then you've got to go to Windows, and you've got to add cases for key down and key up. So it's a lot of work to add a new key, right? To do that for all the keys on the keyboard would be a really big pain in the ass. So we're not going to do that. So that's the first problem, not enough keys. The second problem is, where's my keyboard? There it is. Second problem is, I don't know if you guys remember this or if you actually did it, but back when we did, what was it? The tic-tac-toe game back in like lesson 12 or something. And we wanted to use the keyboard to control it, but the problem was that, let's say we're on the top left-hand square, and this is the top left-hand square, and we press right. What would happen is in the first frame, it would say the right button is pressed, so we move to the right once. But in the second frame, it would say, oh, the right button is still pressed, so we move it again. So you'd move from here to here in the space of, 32 milliseconds, which is like really freaking fast. It's way faster than any human could possibly type. You would have a hard time just getting to that middle square because you just barely touch the key and it would already jump to the right hand side. And we fixed it sort of by locking out the keyboard by saying if one key has been pressed, we lock it out, and then we keep it locked until no keys are pressed, then we unlock it. And that's okay, but it makes the keyboard input kind of nasty, and it's just kind of something bolted on to the end of the keyboard system. It's not a very nice implementation. It would be better if we could build in that single press functionality right into the keyboard. And that is what we are going to do now. So, first things first, let's revamp the keyboard system so that it can use all the keys and do it in a way that is really freaking easy. So I started this system, I did like a different function for every key because it's really, I don't know, it's simple, it's intuitive, and it was great for a beginner. But now you guys are beyond that stage, so we're not going to use this system anymore. I'm just going to get rid of this. So now what we're going to do is we are just going to do one function in the server. And two functions, I guess. On key pressed and on key released. And they're going to take a oh yeah, we need a void here. Void. They're both going to take a parameter, which is the key code of the key that was pressed. And in the private member variable section, we're going to put an unsigned car key states. Wait. Nope, it's not going to be unsigned car. I lied to you. It's going to be bool. It's going to be boolean key states. And we're just going to say there are 256 possible keys. So each element in this array represents one of the keys on the keyboard. Right? And the element's index in the array will just be its virtual key value. Okay, so yeah. We don't need a destructor here because we're not doing anything real dynamic. So that's the server, and that will handle all the keys on the keyboard for us. Pretty simple, ain't it? Now for the client, all we need here is just a bool key is pressed, and this time we take a parameter, which is the unsigned car key code, and that is a constant function because it doesn't change the state of anything, it just reads a value. And yeah, and this part will not have to change at all. Let's go to keyboard.cpp and change this up. Okay, we can get rid of all this crap now. So keyboard client key is pressed, and that was unsigned car key code. Good, so far so good. Now we do server dot key states at key code, and that will get the state of the key at that index. Not bad, not bad. Now here in the keyboard server we have to initialize all of the key states, but we're not going to do it in one big, I don't think we can't even do it in one big initializer list. We have to do it in a loop here. For now I'm kind of doing this shittily. I should do this better. Yeah, I'm gonna fix this here. Keyboard.h. So instead of putting this magic number in here, let's not use magic numbers and let's do static constant int n keys is equal to 256. There we go. And then we'll put n keys in here. That'll work, won't it? Yep. Note that you can initialize static constant variables like this, but only if they're an int. If it's a float, you can't do that. I think that might have changed in the newest revision of the C++ standard, but to be safe, just know that if this were a float, n keys, well, obviously float wouldn't work here at all, but here, error type constant float cannot have an in-class initializer. So if you want an in-class initializer like this, you need to have it be an int. Like that. And then you're all good. Just a little bit of technical detail for you. Alright, x equals 0 as long as x is less than n key. Wait, this is server? Yeah, that's fine. X plus plus. I should have named that index, but whatever. Whatevs. And then we do key states, or is it key state? I think it's states. At x is equal to false. So all the keys, they start off as not being pressed. And now we do, very simple, on key pressed. Fuck, I can't remember what the name of my variable is. IntelliSense, help me out here. Help a brother out. On key pressed. That's what, alright, okay. You want this, don't you? You want this, don't you? What was it again? Unsigned car key code. And key states at key code. Equals true, right? Because if it's being pressed, then we want to set it to true. And again, for the released, we do the same kind of deal here. We copy and paste. Like that. Then I'm going to do this. I'm going to put that there. But we got to make sure to make this false. Okay, so, yeah. And I think that pretty much sets it up. So that's actually a lot simpler in a way. Right? You can agree with me on this one. Now, what we do... what we do here is we got to go to Windows. And on key down, we don't do a separate switch for the parameter. We don't care about what parameter it is. If there's a key down, all we're going to do is we're going to go kserve.on key pressed, and we just pass it the W param. And we do the same thing here. We do kserve.on key released W param. And that should actually just be it. And that should cover every key on the keyboard. How's that for simple? Alright. So, I think that's actually just about it. At least for the first part of our little endeavor here. Let's write a quick test to test this shisa out. Where's my game? Here it is. Okay, so. Now there is one problem with this system. And that problem is we're going to get a little bit of contamination in our system. See, the idea is keep all the Windows related code in windows.cpp. All the Win API stuff as much as possible. We get a little bit of crossover into D3D graphics because it has to know about window handles in order to create the D3D stuff. But generally, the stuff that is linked to the platform, which is the graphics and Windows, should keep all of the Windows code quarantined from the rest of the program. That is what you want. However, we are going to be using the VK codes in our game here. So when we test, like, let me give you an example here. Okay? This moves the dudes, right? Okay, here I'm gonna go if the keyboard, right? If key is pressed, and then we have to put a key code, so we'll go VK what? That's a good one. VK down. Shit, I'm on fire today. My typing skills are off the hook. VK down. So if the down key is pressed, then we want to do shit. I don't know. Now I gotta make like variables and shit. Way more work than I was bargaining for. Okay, you got it. Int y is equal to 0. There. Now what I'm gonna do is I'm gonna go back to game and find out where I was here. Yeah, and y plus and equal 2. There. And then this alpha thing we're going to do 200. Let's put y in here. Okay. So it's very simple. If I press if the down key is being pressed, we just keep incrementing y every frame, and that should move the image down, the alpha image. We're in release mode, build. Good. Whatever. Go. What? I just built it. What is your problem? No. Where? Error. Oh, well, sorry. Jeez, sorry. I was thinking I was still programming in C#. Yeah, you can't do initializers for non-constants. Just so that you know. But you can in C#. We're not programming in C#, are we? No, we are not. So we initialize here. 0. Okay. Now will you let me pretty please use my freaking program? There we go. Okay. Good. Everything's working fine. If I press down, my shit moves at a fairly decent speed. I don't want to move off the screen because I think it'll crash it. Yeah, because I don't have clipping built into that routine yet. So freaking apartment is shaking. All right. Okay, so that proves that our keyboard thing is working. It's working its magic. Let me see that again. 1 second. Kind of looked like it was going. Is that the proper speed? Seems kind of slow. Maybe it's just my imagination. Yeah, it's probably my imagination. What about this? See, that looks slow. I'm in release mode, right? Yeah. 1 second. Alright. I changed something here. I had that timer code around the mem copy here. And I took that off. And that seemed to make it go faster. Although, wait. Why is it saying it's out of date? This is retarded. Yeah, whatever. Seems that running Camtasia Studio really slows this down for some reason. But I can't see where it's slowing down. These numbers are the same. But if I pause the video, it runs faster. That's strange. But it shouldn't affect you guys. I never had this problem before though. Kind of annoying, but whatever. Whatevs. We're still gonna continue. Now, what was I talking about? Oh yeah. Game.cpp. And here. Wait, no. Here. Yeah, okay, so like I was saying, it works fine, but we have to use these these virtual keys in our game, and they're actually Windows stuff. Now, if I wasn't so goddamn lazy, what I would do is I would, what would I do? I'd go to keyboard.h, and I would create an enumeration here. I'd go enum key code, and then I'd do something like, I don't know, down. Oh, you got to be kidding me. There we go. Down is equal to vk underscore down. And then next I don't know, I'd go up is equal to vk underscore up, and so forth for all the virtual key codes in the windows.h file or wherever they are. WinUser or something, I don't know. And that way, and then I'd have to change this unsigned car key code. I'd have to change that to the enumeration. So I'd say key code. Stupid, but anyways. So I'd make all these types of key code type. And in that way, in the actual game.cpp, I wouldn't be using these defines. I'd be using my key code thing here. And then if later on, if someday I wanted to port my game to Linux or whatever, I just have to make a different enumeration for the Linux one, and then I just swap that in whatever. Happy days, but I'm lazy, so I'm not going to make a separate enumeration. We're just going to use the VK codes from windows.h, and that's just the way it's going to be. By the way, I should add in here in keyboard.h, I should add windows.h. I don't have to because in game.cpp we get windows from probably from game.h, right? Game.h gives us what? Yeah, we get it from like D3D graphics. Will probably include windows.h or whatever. I don't know. So anyways, we'll get windows.h will get included in game.cpp either way, but just to make sure we put it in here because we're using VK codes, so we should include Windows. It's just good practice. Now, what is next on the menu? Man, I gotta admit the fact that recording slows down the game is kind of bugging me because I don't think it did that before. And I want to know why it's doing it now. Pisses me off. But, them's the breaks, right? What's more important is... Oh, wait, I know what the problem could be. I think I changed the settings in Camtasia to 30 frames a second. I used to run it at 15. Now I'm running at 30. That's probably why it's slowing down. Yeah, that's good thing. I should change that back. Oh well. Too late now. That'll have to be for next video. It's going to take up a lot of space in my hard drive. Okay, so back to business. So we have successfully implemented all the keys on the keyboard. Any key that you want to use, you can use. Let me just prove it for you. Quickly, I'm going to go... what's your problem? Where is it? Here we go. So we're using down here. I'm going to do VK... What's one that we haven't used yet? F5. And I'm going to build this. And if I press F5, my shit moves down. So as you can see, we can now use any key on the keyboard for input. I hope you're happy with that, because, yeah, I don't know. You should be happy. If you're not happy, then you're just an ungrateful bastard. Now, next thing we want to do is we want to manage shit so that single key presses. We want a system so that we can somehow get input from single key presses, and it doesn't keep repeating like every frame. It won't count it as an individual key press every single frame. For example, let me show you what I want to get at here. If we're gonna be typing in like text, like if you beat a game or something, you get a new high score. You want to be able to enter your name in, right? So let's create a quick little system here for like a text box kind of deal. It won't be a box, but it'll be a text input. So in game.h, we're going to need some data here. We're going to need a buffer to hold the text. So we're going to do character buffer, text buffer, and we'll just say 80 characters. Actually 79 characters, right? One at the end for the null terminator. For those of you who are keeping score at home. So we got a buffer, and we're gonna clear that buffer. And how we clear the buffer is we go, I'll just put it at the end here. Text buffer at 0 is equal to 0, right? We put the null terminator at the beginning, meaning an empty buffer there, empty string. Okay, so now we have our string, So what we want to do is if we what do we think here? I'll leave this in here. So if well, this would be a pain in the ass, wouldn't it? Think about it. To use the system as it is right now, I would have to check if key is pressed for every single key that I was interested in. So that would be A through Z, probably 0 through 1, maybe space, maybe some special characters. That's like what? Like at least 40, 35, 30, almost 40, probably around 40 characters. So I'd have to go if this, else if this, 40 freaking times. Now, that sounds a little like too much work to me. So I'm going to show you guys something a little better. What we're going to do is we're going to create a buffer, a different kind of buffer though. This is a key buffer, different from a string buffer. And the key buffer is going to hold single key press events. And it's going to put them in a queue. So a queue means first in, first out. So you have, if you have an empty queue and then you input number 1, and then you input another one, number 2, and then you input another one, number 3, and then you read something from the queue, you're going to read it in order 1, then you're going to read 2. Then you can input another thing, 4, 5, and then you might read 3, and 4, and 5. That's how the way a queue works. First in, first out. And we can implement that. We could write a class for that too. It'd be kind of like a linked list. Well, you could do it in the like with an array or whatever, but it would suit a linked list quite well. And we could create a class. We could give it functions like enter the queue and leave the queue to input things into the queue buffer and remove them. But that class already exists. It exists in the standard template library. And the thing we have to include is just queue. Now this is a C++ only header. It doesn't work for C. It uses classes. And C++ headers from the standard template library or whatever, they don't have a .h at the end. It's just include queue. And the name of the thing, the class, I think is queue. I'm not sure. Let's try it. Queue. Key buffer. Okay, it's saying it doesn't know what the fuck queue is. And this might be because in the standard template library, everything exists inside of a namespace, which is a way of separating out different identifiers so they don't collide with each other. And in order to specify the namespace you're using, you put this thing and you put a scope operator. So the namespace is std, and then we go stdq. And that tells us we want to use the queue from std. Now, there's still one more thing you need when you use a template class. Queue is a template class. And the reason why it's a template class is because you could have a queue of anything, right? You could have a queue of ints. You could have a queue of floats. You could have a queue of timer objects from my timer class. You could have a queue of any kind of data type you wanted. But every different kind of queue would have a different class definition. And that's a problem because you don't want to have to write a separate class for every single kind of queue you want. Like you wouldn't want to have to say int q and float q? And what if you create new data types afterwards? You won't be able to have a queue for those because no one wrote the queue. So the way it works is there's templates which allow you to modify the way a class works. So the queue class, it can take a parameter which changes the way the class is defined. So queue by itself, it doesn't have a type that it stores. You have to tell it what kind of type it's supposed to be storing. And we want a queue of unsigned cars. That's the kind of queue we want. We want an unsigned car queue. And we'll call it key buffer. And this is going to store all of the key codes that are pressed. Now, what is next? Well, I'm thinking here. Okay, so now we need to get a there's a few ways I could do this. Okay, let's try this. Void on we're going to try this. There's another event in Windows, another message called Windows message care. I think it's called car. Yeah, it is called. And that it informs the window of character press events. But it also does something for you. It if you press the shift key and press A, on key down you'll get a key down for the shift and a key down for the A. And that's it. But if you do it in Windows Message Car, you'll get a capital A. Whereas if you're not pressing shift, you'll get a small a. So it actually it translates shift A into uppercase A for you, which is useful if you're doing like text input, right? Inputting a name or something. So that's good. But there's a problem in that I'm not sure if Windows Message Car will give you messages like for example the arrow keys or other kind of buttons. And that's important because I want to use the queue not only for text input, but also for things like moving around in a menu when you only want to move one square for every key press, as opposed to one square per frame. So the only way to really figure this out is just to try it and see what happens. And that's what we're going to do. Let's, yeah. We'll do kserve dot on car. Now, I'm not sure about car, but I think wparam is probably, again, the key code. And I'm just going to put a breakpoint here. I'm not even going to worry about fixing anything else. Wait, but I do have to define on car. Work. There's a freaking typhoon outside. It's shaking my apartment. Now, where is my keyboard.h? keyboard.cpp, and I want to do a void keyboard server and on car unsigned car key code. No. Yes. I'll just make that simple there. Simple and sweet. Now, back to what I was trying to do here. I want to go to Windows. I want to put a breakpoint here, and I want to see what I can see. So I want to run this in debug. It's going to run slow. That's okay. That's fine. I'm cool with that. Alright. Now, if I press down, do I get a Windows message care? I'm not getting a message for pressing the arrow keys. I'm not getting a message for pressing the shift. Whoa! Woo! That scared the shit out of me. I'm not getting a message for pressing the shift, for pressing control. If I press A, I get a message here. So apparently Windows message care is only for probably alphanumeric characters or symbols. And that, my friends, is a problem. Because I really wanted that functionality of, you know, for example, changing lowercase characters to uppercase if the shift is being held down, or, you know, just general useful shit. Okay, so we're not going to use Windows Message Care right now. It's not part of the plan. We're going to use key down. Make some things a little nicer. One thing it makes nicer is now we don't need to have a separate, where is it? Where are you? No, seriously, where are you, bro? There. We don't need a separate function for updating the queue. We can do that also on key pressed. Right. So, let's get the basics here. We'll start with the basics, and then we'll add the bells and whistles later. That's how we roll. So on key pressed, we update the key state array, and then we have to add the key code to the queue. So we do that by going key buffer. That's what I called it, right? Fuck, I didn't call it that, did I? Or did I make this lowercase? I did. I shouldn't have. It's not my usual naming convention. I also made this one lowercase too. Whatever. Not being consistent. So here's all the functions we have for our queue. And we can push something onto the queue. We can pop something from the queue. Pushing will push something to the back. Popping will pop from the front. So we want to do a push. We want to add something to the queue. And what we want to add is the unsigned car. Now forget about this whole fucking crazy list here, because it's just messed up. You just got to put the name of the thing you want to put onto the queue. So just put the key code. We're pushing key code onto the queue. It's going to line up in the queue behind all the other codes that are waiting. And that's it. And then, my friends, we got to add a function to the client in order to get a key from the queue. And we do that in keyboard.h. We go here, we go, okay, key is pressed. And we'll do unsigned car read buffer or read key. I like read key. We'll do that. And the function read key is going to read a key from the buffer and remove it. So we go here and we go unsigned car. Fuck, I'm not gonna type all this shit out. Too long, too much work. Plus I suck at typing. See? See what I said? It's not my fault. Have you ever seen a Japanese keyboard? These things are fucked up. Fucking there we go. I was wondering where my my IntelliSense went on fucking vacation. There it is. Okay, and to do read key, we do return. Fuck. Car key code. Fuck. Code. I'm getting dyslexic now. Key code is fucking equal to server dot key buffer dot front. So we store the front thing in the buffer into key code. Then we pop the buffer. Server dot key buffer. We pop the thing from the front off the buffer, which, you know, removes it from the front. But it doesn't matter because we got it stored in our key code thing here. And then we do return key code. We return the key code that we stored up here. And that's the way it works. Now there's a problem here. There's a single problem. If you know what the problem was, then you are amazing. Because this error code fucking does not tell you really what the problem is. It's saying cannot convert from constant Q to standard Q. Now the reason why this is up until now we have had the reference to the server as a constant reference, meaning we cannot change the state of the server from the client, which is fine because the client was only basically just checking the state and passing that on to the game object. But now, when we call read key, we're actually removing a key from the buffer, from this buffer, which means we're changing the state of the server object, or the server class, or whatever. And if we're changing its state, then we have to have a non-constant reference. So it can't be constant. And that means that this can't be constant. We have to have a non-constant reference in order to be able to change it. So yeah, I mean, I liked having the constant relationship here, where the client doesn't change anything in the server. It's very tight, but can't be helped. We have to lose it now. So that's what we're gonna do, and we still get a failure. Where is the problem? Overloaded member not founded, blah. Yeah, I know, because I deleted constant from the CPP file, but I didn't from the H file. Try that again. Still failing. We're on the fail train. Cannot convert parameter 1 from constant keyboard server to keyboard server. Right, because this one takes constant as well, but we need a non-constant. Now we still don't have a problem. Overloaded member function not found in game. Right, because I changed it in the H file and I didn't change it in this one. Wait, where's game.h? There it is. There we go. Constant, not constant. So now game's constructor takes a non-constant reference, passes it onto the constructor for the keyboard client, which stores it in its non-constant reference thing, which allows it to change the state of the keyboard server, which allows it to pop something from the buffer. All right. Now, let's see if anything... Wait. I haven't actually tested this system out yet. So, what we want to do is... here. If we press a key, we want to check if key... Wait. Here's the problem. If there's nothing in the buffer, that's a problem. What to return if there's nothing in the buffer? We could return 0. I don't think 0 is defined as anything. We could return 0. I'm going to make another function here. Keyboard. There. So we have keys pressed. We have read key. I'm going to have another function here called peek key. And what peek key is going to do is return the key, the value for the key that's at the front of the queue, the front of the buffer, but it's not going to remove it from the buffer. So it's just going to take a quick peek, but it's not going to actually pop it from the buffer. There's peek key. Now the problem with this system is if the buffer is empty, bad things will probably happen. So let's prevent those bad things from happening. If server.keybuffer.size is greater than 0, then return the front of the buffer. Else, return 0. So we're defining 0 as nothing's on the buffer. Ain't nothing on the buffer. Go home. Nothing more to see here, kids. I hope that is not going to collide with anything in the virtual keys. I should probably check, but I'm not going to, because I'm a bad programmer. Fuck, it's loud. It's getting pretty crazy outside. Anyways, let's change read key to also not be stupid. So we'll go if server.keybuffer dot size is greater than 0, do this stuff. Else, return 0. There. So we're defining 0 as meaning empty buffer. Now, brr. Go to game.cpp and we'll do keyboard.peek key is not equal to 0. Then, wait, I got a better idea. Keyboard.peek key is greater than A. Oh, by the way, I should let you know this, but the virtual key codes, there's no virtual key codes for the alphanumeric things. They're just, the code is just the ASCII code. So there is no VKA, it's just A as a character, ASCII code, whatever. So if the peek key is greater than A, greater than or equal to A, and less than or equal to, wait, Z. So we'll only deal with keys from A to Z here. I could see a problem here, and a potential problem. I'm going to do this. While there is a key on, while there's a key press in the buffer, is equal to kbd dot, we'll read a key off the buffer. As long as there is any keys in the buffer, we'll read a key from the buffer. And then if the key press is an alphabetical key, then I can't do string cat because you need 2 strings for that. I want to concatenate this character on the end of the string buffer I have in memory. You see, this is when fucking std, the standard template string, comes in very handy. But I didn't make it a standard template string. I'll use those very soon, because they're way more useful than fucking working with C strings. Okay, so to do this with C strings, what we'd have to do is we'd go int length is equal to string length of, I forgot, text buffer. Did I type it like that? Yeah. Now this gives me the length not including the null character. I fucking forget. Where is my goddamn thing here? Where's my Windows? Where's my internets? Son of a bitch. C++ reference. I think that's what it is. C math. Yeah, that's what it is. Okay. String. C string. There we go. String length. Copying other. There we go. Get string length. Yeah, but what kind of length? Tell me the amount of characters between the beginning of the string and the without including this terminating null character. Okay, so my string returns 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, fine. So, that's the number of actual characters, not including the null terminator. Fine. So, in such a case, we would say text buffer at length, because that would be the location of the null terminator, right? The index of the null terminator would just be the length of the string. Is equal to key press and text buffer at length plus 1 is equal to 0. So we add a null terminator after the key press that we added. There we go. Alright, so this will append a key press onto the end of our text buffer. Now, if we want to print that text buffer out, all we got to do is go graphics.drawString text buffer int x int y. We'll say 0, we'll say 50, and we'll say fixed sys, and we will say, I don't know what color we want here. Red, green, blue. Let's go with blue. Okay, so this is how it should work. Oh, you fucking gotta be kidding me. What is your freaking problem now? Now what? Warning, warning, error, missing stuff, and also this stuff. There we go. Okay, finally. Let's see if this works. Start without debugging. Yes. Sure. Oh, it's in debug mode. Okay, now if I press a key on the keyboard, I should get stuff coming up on the screen, but it's not. And that kind of pisses me off. Right. Alright, so, doesn't work. Why not? Oh, I hate you, program. I hate you with a vengeance. So many places where things could go wrong. Well, how do we do this? Well, first we just check a few basic things. Read key and peek key. Yeah, that's being called. And key pressed. Make sure that I implemented things on key press here properly. On key pressed, push the key code. That seems fair enough. If the size is greater than 0, return that. Otherwise, return 0. Size is greater than 0, return this. Otherwise, return 0. Good. Okay, so that seems to be right. And of course, we're calling on key pressed in there. In Windows. Yeah? Yeah? Okay. Key down. Okay, so... well, let's add some breakpoints and see what we're going to get. Put one here. Aw, shit. Okay, well, first I'll put a key code. I'll put one here. Yeah, debug. Start debugging. Go for it. Okay, I'm going to press a key. And it came here, so that's good. But, okay, key press is equal to read key. Let's see what kind of key press it was. It was G, which is good because I'm pretty sure I pressed the G key. I wasn't actually looking at my keyboard, but it was in that vicinity. So, fuck, I got lowercase, but these things come in uppercase. Shit, I didn't know that. So the VK, the what is it? Windows message key down and key up. It gives you the uppercase versions, not the lowercase. So, all I got to do is go here and go here. That should work. Maybe. Maybe, baby. Let's try it out. A M T P X Z J. See, if I hold it down, it also gives you that repeating thing. You can turn that off if you want. So this is working fine. Single key presses give me single inputs. And if I press some other keys, like the space key or the arrow keys, it doesn't work. Because I'm ignoring those key presses, right? I'm only handling the ones from A to Z. Yeah. So this will give us, using peek key and read key, we can get single key presses. Now it might happen where you're in a mode where you're just looking at the keys like they're, I don't know, like they're a gamepad, right? So you're just checking key states and you don't worry about key presses. And if you keep doing that, what'll happen is the buffer will just keep getting fuller and fuller and fuller. So then if you, let's say you change the mode of the game to where you're going to input some text, this full buffer is just going to read out and you're going to get a whole bunch of bullshit jamming up into your text box because the buffer got super full from when you weren't clearing it out. So what you should do is, if you were in a mode where you're just checking key states and all of a sudden you're going to start reading key presses, you should clear the buffer. You should flush the buffer before you start reading the key presses. Otherwise, you're going to get all the garbage in the buffer from before. And how you do that is we're going to add a little thing here. And we're going to do void flush buffer. So the client should be allowed to flush the buffer. And again, this is not constant at all, but whatever. We're beyond caring about that anymore. And here we do void. Actually, we don't have to put a function in here because the client can access this stuff directly. So it's not a big deal. Yeah, so what we're going to do then is we are going to go to keyboard.cpp and we'll go up here somewhere, peak key, good, and we'll do void. I don't want to type this out. Are you fucking kidding me? Where's my goddamn IntelliSense? I hate you, game and everything. There it is. Fucker. Flush buffer. And we'll just do server dot key buffer dot empty. Wait, what is, I'm not even sure if this means empty the buffer or if this means is the buffer empty, because it returns a bool, so it could conceivably mean empty the buffer, or it could conceivably mean check if the buffer is empty or not. That's not what I wanted, fucker. White power music. Where is it? There it is. Where is my thing? STL containers. Q. There it is. Okay. Empty. Test whether the container is empty. Yeah, fuck. Damn it. That is not what I want to do. I want to empty the entire container. Tell me I can do that. There's no freaking function to empty the container. It just, oh, that pisses me off. You tell me I gotta delete every single freaking, I hate you. Why isn't there a function to just clear out a buffer? That pisses me off. You suck, STL. Okay, whatever. Whatever's brah. I don't care about you anymore. Empty. Yeah. That's what I was afraid of. I was afraid that it might just be a test thing. So, while not empty, pop. There's how you flush a buffer. the ghetto way. Ghetto style. Okay, whatever. So we flush the buffer, and everyone is happy. Why did I put... Did I do something stupid? No, I didn't. Never mind. Okay, so... Yeah. That's how we flush the buffer. And you should always flush the buffer if you're, like I said before, if you're changing modes between a key state checking mode and a key press reading mode. Because otherwise you're going to have a buffer full of garbage and it's all going to empty out into wherever the garbage is going to go, and it's going to fuck you up. And it won't be happy times. So, yeah, just remember that. So, I think this is about where I want to put this thing. There is another kind of... yeah, I guess I should do one more thing here. Yeah. Okay. Yeah, right now we can only get lower or uppercase letters. But what if we want lowercase letters? Well, we have to actually do that ourselves. We have to modify. We have to process. We have to do stuff. Let me tell you what I am trying to say. In the key press, or in the key down, where is it? On key pressed. Yeah. Our game is not going to support caps lock because I'm too lazy to figure that out right now. But what we can do I want to see if VK shift actually exists. Go to definition. Okay, it does exist. Okay, that's good. VK. I wonder if there... Why isn't there like a VK left shift and a VK right shift? R shift, L shift. Used only as parameters to get async. No other API or message will distinguish left and right keys in this way. Okay, so we don't have to worry about left and right shift. All we have to worry about is if shift is currently down, then we want to make stuff uppercase. Yeah. So, man, if key states at VK underscore shift, fucker. Shit? No, shift. It's more work than I wanted to do today. This was supposed to be like a 40-minute lesson, I swear. Fuckers. Okay, so if shift is being pressed, then we gotta do stuff. You hear me? We gots to do stuff. Else, we don't gotta do stuff. So we just do this. Okay, so if shift is being pressed, okay, we're not gonna handle the symbol keys yet. Should we handle them? Fuck. I don't want to handle the symbol keys right now. If key code is greater than uppercase A and key code is less than uppercase Z, key code is equal to key code. Now there should be a function to switch uppercase to lowercase. Oh wait. Shit. That's not how it works. If the shift key is down... Oh, this is going to be so fucking complicated now. Okay, so if the shift key is down, then we leave it alone, right? And if the shift key is up, then we have to convert the uppercase to lowercase. Fuck. That's going to make my life more difficult. So, let's reconsider for a second here. Okay, so if shift is being pressed, then just do your thing. And if it's not being pressed, then key code is equal to key code. Oh fuck, no wait. Shift is being pressed. Yeah, whatever. First we check to make sure that it's an alphabetic key. So, key code is greater than or equal to A. Code. Why did I type case? That's not even close. And key code is less than or equal to Z. There. Now there should be a function called toLower, and it does exist. Thank you very much, Standard C library. You have finally proven yourself useful this one time. Alright, so what this will do is this will, if the shift key is being pressed, it'll leave the key code alone. But if it isn't being pressed, wait. This is actually kind of stupid. I should remake this so that the push is at the very end here, and fuck it, I won't do it right now. But here you can see that if the shift is being held, then you just put the key press onto the buffer. Don't even do anything to it. Just put it right onto the push it into the queue and forget about it. But if shift is being pressed, then we check to see if the buttons are a alphabetic button, and if it is, no, if shift isn't being pressed, then we check to see if it's alphabetic, and if it is alphabetic, then we make it a lowercase letter and then push it. But if it is not alphabetic, then we just push it as it is. And that way, I should be able to get upper and lowercase letters. So let's type. Oh, you fucking cocksucker, I'm not getting anything. Only the uppercase is showing up. Cocksucker! Oh, I know why. I know why. I know why. Do you know why? Think about it. I'm giving you a chance. Thinking. Are you thinking? Are you thinking? Are you still thinking? Too late. It's like this. Because I was ignoring the lowercase ones in the actual game, game.go. But now I'm not ignoring them. So now it should work. And now I can go lowercase a, and fuck, it's still not working. Oh my god, now even the uppercase ones aren't working. Now I'm just totally fucked. Okay, what did I do wrong? I must have... If key press is greater than this one. I think lowercase is actually a bigger number than uppercase. It should be like this, between uppercases A and lowercase z. Because the lowercase letters come after the uppercase in the ASCII code. I'm just saying right now because I have no idea, but apparently that's the way it works. Okay, now if I type lowercase, I get lowercase letters. And if I type uppercase, I get uppercase. And lowercase and uppercase, and fuck. This is amazing. This is amazing technology. Uppercase and lowercase. Alright. Now you could do something similar for, well, fucker. You could do something similar here for all the other keys in the keyboard. Like, for example, the number keys, you could convert them to symbols depending on the shift key. And, yeah, you could also what is it? You know, convert other things like brackets and stuff like that. Well, in a Japanese keyboard, these brackets go to this if you hold shift. And these two keys go to this if you hold shift. But you get the fucking idea, right? You can, oh god. The problem is if you do it like this, like for example on my keyboard, if I type 1, I get a 1, and if I type, I get an exclamation mark. Is that the same in America? I can't remember. But if I type 2, and then if I type shift 2, I get a quotation mark. But it depends on the locale and the type of keyboard you're using. So if we hard code that shit in here, then we're fucked in the ass. God damn it. Now there's probably there's a function in WinAPI that will take a key code and convert it to its uppercase version. But I'd be fucked if I know what that is. Now, you know, there's other solutions, maybe, like before, like that case. Windows message character. And that might let us, that'll do all the conversion for us. So that'll convert, you know, capital letters or numbers to symbols, depending on whether the shift key is pressed or whether the caps lock is down or whatever, which would be cool. But like I said before, that will not register arrow keys or whatever. Now there is a third solution, which is we use 2 separate queues. One queue is only for Windows message care messages, and that queue will only take those things in, and we can use that for like inputs to text boxes and shit. And then there's another queue, and that queue is will just use standard Windows message key down messages, and it will, you know, it won't have the processing for shift or whatever, but it'll register individual keys. So we could do 2 separate queues. And that's one solution. I don't know. I would prefer to be able to do it all in one queue, but now that I think about it, that probably isn't the best way to do it. It's probably better to have 2 separate queues. I mean, the amount of there'd be some wasted space and some wasted processing, but it is super negligible compared to anything else, so it doesn't really matter. That's not an issue. In a way, it's not as neat as being able to do everything with key down, but I think that's what we probably should do. So we should have 2 separate queues, and one queue handles Windows message care, and one queue handles key down. And everyone would live happily ever after. But I'm not going to do that right now. You guys get the idea of what I'm trying to show you here, I think. So, you guys can, you know, do with this what you will. This will give you a good head start on whatever kind of keyboard you want to do, keyboard input you want to do. And as for the details, we'll just have to wait. I'll probably use something like this for the game that we're going to be making in the next lesson. We'll actually start it in the next lesson, I promise. And if it becomes inadequate for some reason, then I will modify it at that point. But for now, yeah, I think this will just do. It's not pretty, but it'll have to suffice. And if you want something better, well, I've given you a bunch of ideas, and you can just go with it. Remake it in your whatever image you want. So that's the end of this lesson for keyboards. A lot longer than I wanted it to be, but that's what happens in the Chili tutorial series. Shit gets long. Deal with it. Next lesson, definitely gonna start on the game. I'm making fairly good progress in getting ready for that, in making the tool that I'll be using to make the sprite for that. So in another week or maybe 2 weeks, I should be able to start off with the first lesson for making the platformer, and I should have at least the running animation done for the sprite, and I'll have the tool finished, so it'll be pretty easy to make the other animations. And yeah, that is about it. So yeah, you guys keep it real, and I hope you find this keyboard shit useful. As always, any questions or comments, feel free to drop by the forums, and I will hit you back when I can. So this is Chili signing off.